Hey everybody, back with another Polars tutorial. Hope you're all doing well. Today I'm going to be talking about how to do joins in Polars using Python. And it's very rare in any kind of data science project that the input data set with which you're working is going to have all of the information you're ever going to need to answer whatever kind of question it is you have. And so here I have some sample data from just that I downloaded from the internet to practice joins with, a customer table, an orders table, and a products table. And so let's say we were in a project where our task was we wanted to understand the buying behavior of our customers. Well, if we just used our customer table here, we wouldn't get very far in that because all we have is the customer's name and the country in which they presumably live, along with what I'm assuming is a pseudonym for a name. Nobody's named customer 1001. So we'd just be kind of stuck. And so in order to get some relevant information about these customers, we would have to add columns from this orders table. And so we would have to find a way to join this customer table to this orders table. And then if we wanted to understand what they actually ordered, so what products they actually bought, we would have to find a way to join this resulting table, this table that resulted from the join between the customers and the orders, to this products table we have here with product names as well as the price. And so before you actually join tables, you need to know how these tables relate to one another. And so we have three tables, and these tables relate to each other in the following ways. So first we see that the products table relates to the orders table, and it relates to that table. In other words, we can identify records to match by through the product ID. And so let's take a quick look at it. So products and orders. So here's the products table, and they both have this product ID. And so this product ID on this table uniquely identifies each record. In other words, it only occurs once. Now this orders table has quite a few more records than the products table, and because we would expect this product ID to occur more than once. So in other words, this is a join key that we can use to join to one another, but the relationship is a many-to-one relationship. And it's a many-to-one relationship because products can be ordered multiple times. And so again, we would expect this product ID to show up multiple times in this table. And so then the other relationship we have is we can see that customers relates to orders by customer ID. So in other words, we can link our customers table to our order table by using that customer ID. And again, this relationship is a many-to-one relationship as well because customers can make multiple orders. So each time a customer makes an order, there's going to be a new record for that customer in this order table. And so what kind of joins do we need to do to properly join these tables? And there's a lot of different joins you can do in Polars. I'm going to keep it very simple and just talk about the ones I use 99% of the time. First, there's the inner join, and that's where we keep only the records where the join key is present in both tables. So in other words, if we joined this customer table to the order table, and this customer ID 1001 was not present in the order table, that would get dropped in the resulting data set. That record would get dropped in the resulting data set. And then there's a left or right join, and that's where we keep records in a designated table, regardless of whether there is a matching key in the other table. And if that sounds a little difficult to understand, so let's say there's 400 records in this customer table, and let's pretend like we don't want to lose any of these records, and we don't care if there isn't a matching key in the orders table. It might be a little strange that a customer never made an order, but maybe they were just onboarded and they just haven't really made an order yet. But regardless of what happens, we always want there to be 400 customer records. Or we would always want these original 400 customers retained after the join. So in this case, if customer 1001 was not in the order table, that they would still be there. It's just that all these other columns would show up as missing after the resulting join. So order ID would be missing, product ID would be missing, quantity would be missing, and so on. Order date. Okay, so now now that we've kind of laid the foundation, let's get into our actual join. So let's say our task is to get all of the orders made by customers and drop any customer record without an order. And so to do that, we would do an inner join between the customers and the orders table. So here's what the syntax looks like for polars joins. It's very simple if you're familiar with something like pandas or something like that. And so I'm going to call this resulting table customer underscore orders. And so to join a table, I know my spacing preferences are a little strange. Let's let's try to ignore that. So you start with the table you want to join by, and so we're going to join customers, and then you do .join, and then there's going to be 3 arguments that you're going to use virtually all the time. So the first argument is going to be the data set you want to join with, and so we're joining to orders. And then second on is the key or keys that you want to join by. And so here we want to join by customer ID, which makes sense. Customer ID is the column we would link the 2 tables by. And then how is where you specify the type of join you want to do. And here we're doing an inner join. So we're only keeping records where there's a corresponding, where a customer ID is present on both tables. And then we're going to take that resulting table and we're going to sort it by customer and order ID just to really kind of clearly see the results of what we're doing here. So I will go ahead and run this and we can take a look at the results. Okay, and there's the result of our join. We see we have 4,000 records. And since we see that we have 4,000 records, that corresponds to the number of records in the orders table. And so what that means is that all of the customer IDs in this table were also present in the orders table. So that means there were every single customer had made an order, which is good. It means our data is nice and tidy. And so now there's a difference though. We do see that our customer ID repeats now. So that means that this customer made, how many is this? 1, 2, 3, 4, 5, 6, 7 orders. And there's the unique order ID. So customer ID repeats, but order ID does not. And so that's important to understand because it lets us know the relationship between these 2 tables, and it kind of emphasizes that this is a many-to-one relationship. And so all the customer information repeats now, but the order information doesn't, because in this join that we did, the customer information is no longer unique, but the order information is. Okay, so the second type of join we'll take a look at is a left join. And so here the task is we want to get the products included on each order, and we want to keep all the records on the order table, even if there's no corresponding record present in the product table. And the method we're going to do this is to do a left join between the orders and the products table. So here we're going to have 4,000 records regardless because we're doing a left join. And so the way we do this is, again, we specify the new table we want to create. I'm calling this order products. And so we're joining orders to products, and we're going to join it on product ID, and in how we specify left. And so we're going to have 4,000 records regardless of whether or not there's a corresponding product ID key in the orders table. Because this is a left join and we're telling polars that we want to keep all the records in the orders table regardless of how many records we're able to join by. Okay, and so there's our resulting join. We see that we do in fact have 4,000 records. And we now have all of the product information on our order information. All right. And so now we're going to join all 3 of these tables so we can get all of the information from orders and products onto our customer table, so we could theoretically do our project on customer buying behavior. And so let's say to do this, we would want to get all of the products that were ordered by customers. And so notice that I'm using the names of the tables here. So we want all of the products that were ordered by customers. And so that gives us an idea of the join path we need to take here. And so the method we're going to do this is first we're going to do an inner join between customers and orders, and then we're going to take that resulting data frame and do an inner join with products. So we're only going to keep records where there's a corresponding relationship between them. And so I do this in just one join. Oftentimes you see people do in their code, they'll do something like this. They'll do separate lines for each one. So customers dot join. Then they'll do something like this. And this is fine, there's no problem with this, but oftentimes you can really clarify your code by just doing a method chain with your joins. That's what I prefer doing, and it can look a little intimidating if you don't really join data this way, but I'll walk you through it. I'll walk you through what the method chain is doing. So I'm calling this resulting data frame 3 tables, and so we're starting with customers, and then we join customers to the orders table on customer ID, and we specify that this is an inner merge. And so at this point, after this join takes place, it doesn't get returned to 3 tables just yet. It's an intermediate data frame that contains the resulting join between customers and orders. And so if there's another method specified after that, what Polars is going to do is send that intermediate data frame to that next method to act as standard input for it. So the standard input of the second join we're doing here is going to be the result of customers and orders. And so we take that intermediate data frame and we join it to products on product ID, and we're specifying that it's an inner join. And then we're going to take that resulting join of those 3 tables and sort it by customer ID, product ID, and order ID. So that's really all there is to it. I always prefer to do my joins in method chains just because it's kind of easier for me to follow. I kind of think like a computer, I guess. And we'll just take a look at that and see how the results look. Should be all at the bottom here. Okay. Okay, so here's our table. So here's the customer information. And that makes sense that it's specified first because we started with that table and merged other columns onto it. And we have a customer ID that repeats now, which makes sense because a customer can make multiple orders. Same with the customer name and the country. And then we have the order information that each of these customers made and the product information. Okay, guys, so that's a very brief and, well, maybe not brief, but a very simple introduction to how to do joins in Polars. There's a lot of different kinds of joins you can do in Polars, and there's a lot of different options you can use to validate those joins. I didn't go over those because I just kind of wanted to keep this video introductory, but if there is any interest in these more advanced join features, let me know in the columns, and I'll think about making a video for that. So thanks so much, guys, for watching, and I hope you have a good rest of your day.